Alright guys, our next video is section 2.6. We're going to talk about different operations we can do with functions, the four basic operations, then composite functions where we're basically composing, hence the word composite, composing one function made of multiple other functions. Okay, we start with operations with functions, and the good thing about this should be one of the easier things that we do. When we add, subtract, multiply, or divide functions, it's exactly what you might think it would be, where we're actually just adding, subtracting, multiplying, or dividing the individual functions. Okay, so f plus g of x. Okay, take note of the notation. Okay, this means f plus g of x, which is also the same as, and you can take these and you can rewrite it both ways, just f of x plus g of x. Okay? F minus g of x can also be rewritten as f of x minus g of x if you want to evaluate it. F times g of x, or f again times filled in circle means multiplication. Okay, make sure you take note that this is a closed circle, means multiplication here. Okay, this also would mean multiplication. Okay, just like when variables are next to each other, or a coefficient in a variable in algebra, that means multiplication. Okay, that would be the same as f of x times g of x. And lastly, f divided by g of x is the same thing as f of x divided by g of x, where g of x does not equal 0. If g of x happened to equal 0, it would be undefined. We wouldn't be able to do that. Okay, pretty simple. Pretty simple. Quick example here: if we had something like f of x equals 2x minus 4, and g of x equaled, I don't know, 5x. We could do all of these operations. Okay, we could do something like f plus g of x. Alright, if we were to do f plus g of x here, then it would be f of x plus g of x, which would be 2x minus 4 plus 5x, and we always want to simplify, in this case, to 7x minus 4. We could also do a different operation. We could also evaluate using an input, a numerical input. So we could do something like f times g of 3. Okay, so different operation. We did addition up here. We're doing multiplication of these two functions down here. Okay, and then 3 would be the same as f of 3 times g of 3. Well, f of 3, 2 times 3 minus 4. G of 3 would just be 5 times 3. 6 minus 4 is 2. 5 times 3 is 15. F times g of 3 happens to be 30. Okay, so just a couple examples there for you. All right, going pretty quick through this initial part of our section 2.6 notes because fairly simple. Okay. All right, composite functions. All right, the notation just a little bit different. Open circle. This reads f of g of x. That's how you would say that. Okay, and really, it kind of turns into the first thing that I would suggest is turning it into this type of written notation, where we have an interior function and an exterior function. Okay, in this case, our interior function would be g of x. Our exterior function would be f of x. We're always going to start by evaluating the interior function. Okay, so how do we compose a function of another? We're going to evaluate the interior function, and then plug that expression or value into the exterior function. Alright, so let's say, again, for the sake of, let's say f of x was 2x minus 4, again, and g of x was 5x. Okay, quick example here. If you were asked for f of g of x, first thing that I would do is rewrite that as kind of an interior and exterior function. It is not needed, not mandatory. Let's evaluate the interior function. Well, evaluate might be a strong word, but we already know what g of x is defined as. So let's place this expression in there for g of x. Okay, so it's really kind of a series of substitutions here. We're going to take that 5x and we're going to insert it where it says g of x in our problem. And then this notation, f of 5x, means plug in a 5x anywhere you see an x in the f function. So now we can take this and substitute it right in there. Here comes our final simplifying. F of g of x would be equal to 10x minus 4. We can also do things like this numerically, where we're actually evaluating for a function. Let's switch it up and let's go g of f of negative 3. Again, my suggestion, let's rewrite this as an interior and an exterior function. Evaluate the interior function first. So let's do f of negative 3. F of negative 3 would equal 2 times negative 3 minus 4. F of negative 3 would equal negative 10. And again, series of substitutions here. Now that I know what f of negative 3 is equal to, let's just substitute it right in there. And now all that's left of this part, how to find g of f of negative 3, is to evaluate g of negative 10. Again, that just means take our negative 10, plug it in anywhere you see an x in the g function, and I would get 5 times negative 10. And we have found that g of f of negative 3 is negative 50. Okay? Now what I showed you was numerical. Okay, we were given the algebraic. We were given the algebraic representation of these functions. Okay, we also will do some examples of seeing two functions given graphically and how we might find g of f of negative 3 graphically. Really, we'll find f of negative 3 on the graph. Whatever that y value is, we then input it here. We do g of that y value that basically becomes the input for the g function, and we'd go look at the output or the y value once again, and that's how we would do that. You also will see numerical representations of functions, basically a table of values that you'll be able to, again, go through that same process. Okay, we could extend this as far out if we wanted to be really challenging. We could do g of f of g of f of f of f of 2. Okay, and you're just taking it one step at a time. Into the innermost function, evaluate. Then the next one, evaluate. Next one, evaluate. We will challenge you just a little bit on a couple of these examples when we get to it in class.